Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. In our previous video of our series of organic compounds, we were discussing about the nomenclature of branch chain hydrocarbons. So we will take our lecture ahead and we'll move on to functional groups. Okay, so in the previous classes or in the initial classes, what I have said you is carbon atom can form 4 bonds. Okay, so if it is forming all its 4 bonds with its hydrogen and carbon, okay, if it is satisfying all its need for 4 electrons or its tetravalency with hydrogen or other carbon atoms, then it is called or it falls under the category of pure hydrocarbons, right? We were calling it hydrocarbons. But carbon also has a tendency to form bonds. Like carbon basically is in need of electrons. So when carbon or when anybody is in need of something, then if it is getting that from any source, it will pick it up. So carbon, if carbon is finding electrons from any other sources or from any other atoms, then will the carbon be like, no, I will not take electrons from the other atom? No, obviously. It can take up electrons from other atoms or atoms other than carbon and hydrogen only, right? So for a carbon atom, one carbon and one hydrogen is its family. Okay, carbon and hydrogen, they belong to a one particular family, and that family we call hydrocarbons. But if some other atom is coming from the apart from the family, if some other atom is coming, then that atom becomes a guest in the family of hydrocarbons, and that guest is given a special name or a special treatment, and that guest is particularly called as hetero atom. So I can say any atom other than carbon and hydrogen in an organic compound is called a heteroatom. Okay, hydrocarbons basically belong to one particular family, and any other atom other than carbon and hydrogen are known as heteroatom. So what those heteroatoms can be like? You can encounter atoms like chlorine, oxygen, nitrogen, fluorine, bromine, iodine, etc. Okay, all these atoms can also, or they also have a tendency to form bond with carbon. So they fall under the category of heteroatom. Now what happens when this heteroatom gets linked with carbon? Then the property of the pure hydrocarbon changes, right? So when this heteroatom forms a bond with a carbon atom, its property changes. It like modifies. Whenever guests come to our house, do we belong like in general how we are? Do we belong like that in front of our guests? No, we give them some special treatment, right? So when these heteroatoms get attached to carbon atoms, they also give them special treatment, and that property changes. The property of the carbon atom changes. So basically the heteroatom decides the property of the organic compounds then. Okay, the heteroatom which is present in the carbon chain or carbon ring, whatever it is, which is present in the organic compound, that now determines the entire property of heteroatoms. So that heteroatom decides the function of carbon atoms or the organic compounds, and that's why this heteroatom is called as the functional group. Okay, it is that particular group which decides the property of the organic compound in hand. Okay, so what are functional groups? Those groups containing the heteroatom which determines the property of the organic compound. Okay, that heteroatom which determines the property of the organic compound is called as the functional group. And organic chemistry has blessed us with a lot of functional group, and depending upon the functional group, the organic compound falls into a category of different homologous series. Okay, alkane was belonging to a particular homologous series, Alkene was belonging to another particular homologous series, alkyne was belonging to another homologous series, right? And that homologous series, the individual element of the homologous series, they were differing by a CH2 group. Okay, the members of the homologous series, they were differing by a CH2 group among themselves, and therefore the presence of heteroatom, they, like, depending upon the heteroatom, the compounds will fall into separate homologous series, and organic chemistry has given us a lot of homologous series. To name some common, we have, the first is, if there is a pure hydrocarbon, I'm picking up or I'm removing one hydrogen atom, I'll be attaching a halogen group. Okay, I'm not showing here the presence of hydrogen, but that doesn't by any means signify that the hydrogen atoms are not present. Carbon without hydrogen is incomplete. Okay, so carbon, in any organic compound, carbon definitely forms at least one bond with hydrogen, but hydrogen has to be there. So I'm just writing the carbon skeleton. If there is a carbon atom and the halogen atoms are given a special symbol, like we have how many halogens? Normally functional, we have 4 halogens, which is fluorine, chlorine, bromine, iodine, right? So functional groups for these halogens, they have a common symbol. We write it as X. Okay, C bond X. This becomes one category of homologous series. Now here X is the functional group. The symbol for fluorine is F, chlorine Cl, bromine Br, iodine I. Okay, so it can be a CF bond, a CCl bond, a CBr bond, or a CI bond. Okay, now those category or those organic compounds which have a like halogen group with them are called as halides or haloalkanes. Okay, the particular organic compounds having a halogen atom in them are called as or they fall into the category of halides or haloalkanes. So IUPAC, for their nomenclature, what IUPAC has said is, like, how it is formed basically. Haloalkanes means alkane was initially there. We removed one hydrogen from that alkane, particular alkane, and we placed a halogen group in that. That derives or that gives us the haloalkane. So if I'm saying CH3Cl, so how it is initially formed, if we see, then methane was there. From methane, I got rid of one hydrogen atom, I removed one hydrogen atom, that became CH3, and to that I attached one halogen atom, that is chlorine, and I got my CH3Cl. So its name is basically derived from what is its parent compound? The halogen. So the name is haloalkane. So for IUPAC nomenclature, we have to add a prefix to it, and the prefix is halo. Okay, and this halo is a general term. Now this halo, the name of this particular halo will depend upon the group which is attached. If it is fluorine, then the name will be fluoro. If it is chlorine, the name will be chloro. If it is bromine, the name will be bromo. And if it is iodine, the name will be iodo. Okay, these are the prefixes which we have to attach or we have to associate with the name of the alkanes for those functional group carrying a halogen atom. Okay, so if I'm saying the name example which I have given, CH3Cl, now this has been derived from the general formula CH4 from methane. The parent carbon is methane, but here I'm having a chlorine group. So here the name becomes, instead of methane, the name becomes chloromethane. Okay, like prefix of halo is associated with the parent alkane, and I get my desired the nomenclature of my desired functional group. Okay, so we have the first functional group is that of the halides, and the bond is formed as CX. The general representation of a halo group is bond X. Okay, X stands for, X can be fluorine, chlorine, bromine, iodine. Okay. Now, the second functional group which we are moving on to is if COH is attached. Okay. OH is attached. These functional groups are called as alcohols. Okay. These are not the alcohols which you understand or we generally use. That is in organic chemistry. Alcohols are those organic compounds where the carbon is attached to a hydroxide group, this OH group. Okay. If the carbon is attached to an OH group, then that belongs to the functional group of alcohols. Okay. So for alcohols, there has to be a carbon-oxygen bond, a COH bond must be present, and the name, if I see the general formula, suppose I was having CH4 methane, I removed one hydrogen atom from it and I got CH3OH. Now I don't have to it makes our task easy, because if I'm having a long chain of hydrocarbons and somebody is asking you to what category it is falling into, you don't have to look into the number of carbon atoms or how many hydrogen atoms are associated or whatever it is. You simply have to give a look to the functional group and you can come down to the name of the, or at least the functional group to which, or the category of homologous series to which the particular element is belonging. So if I'm seeing here this compound, then you will just see the OH group and you will say this is an alcohol. Okay. If I'm saying I'm having a long chain of carbon atoms and here at the last OH group, you need not to count any of these carbon atoms or reduce its name or something, anything. You simply have to look at this OH group and you will say this compound is falling under the category of alcohols. Okay. So now what is the naming of alcohol? How the naming is done? In case of alcohols, IUPAC has given us a formula. We have to associate a suffix of OL to the parent compound, okay, or the parent hydrocarbon. We simply have to attach or associate a suffix of OL. Now if I see, I'm giving you a structure CH3, CH2, CH2, OH. Okay. So if from by seeing the OH group, I can say this compound is falling under the group of alcohols. Now if I have to do the nomenclature, firstly I will see the number of carbon atoms. How many carbon atoms are there? 1, 2, 3, 3 carbon atoms. And for 3 carbon atom compounds, my word root is prop. Okay. And as all the carbon atoms are singly bonded, therefore the word, the suffix which should be associated with it is ANE, and this is falling under the category of alcohols. So another suffix OL is associated with it. But see, here what discrepancy has started is, there is one E and O together. Two vowels are together, but this is not possible. This cannot be accepted by IUPAC. So what it has done is, it has removed this E from the parent alkane and simply associated the suffix of the functional group. Okay. So what the name becomes here? Propanol. Okay. The E which we are having at the end of ANE alkane, we cut that, omit that E, and we simply place OL as the functional group here, or the suffix for the functional group alcohol. Okay. So if I see another example, if this was CH3OH, then it's derived from methane. So it should be methane, OL as the suffix, E got omitted, and we get the name methanol. Okay, methanol, ethanol, propanol, butanol, pentanol, likewise. Okay. Now, the next functional group which we will be arriving at is for aldehydes. Okay, the next functional group is that of aldehydes, and their general representation is C double bond O H. This is the functional group, or it can be simply written as CHO. Okay, if anywhere you find this name CHO, that signifies the group of, or the functional group of aldehydes. Okay, so IUPAC, for its nomenclature, IUPAC has given us the rule we have to associate a suffix Al to the parent hydrocarbon chain. Okay, again, if I see the example, CH3 CHO, this is falling under the category of aldehydes. Now what happened? See, when we were having alcohols, we had a OH group associated to a carbon atom. Therefore, while counting the number of, while choosing the parent carbon, we just have to count the number of carbon atoms. We don't have to count the number of heteroatoms. But see, in case of aldehyde, what happens? In the functional group itself, we are having a carbon atom. So that carbon atom has to be counted in the parent chain. If I'm having aldehyde, or for that reason, if I'm having any like functional group having a carbon atom in it, then that carbon atom has to be included in the parent chain. Okay. So here if I'm seeing this, then how many carbon atoms I'm having? If I omit the functional group, I was supposed to have only a single carbon atom, but my functional group is also having a carbon atom. So I will take that, or I will consider that also in naming the parent carbon atom. So here I'm having two carbon atoms. Okay. One for the alkyl group and one for the functional group. Okay. So here I will be getting, the word root for two carbon atom is ith. Right. And as all are singly bonded, and here you will see a double bond is there. So is it alkene? No. Because here the double bond is between the carbon atom and the heteroatom. But we were deciding alkane, alkene, alkyne by simply looking at the number of bonds between the two carbon atoms. If the two carbon atoms are having single bond, they are alkane. If both the carbon atoms are having a double bond between themselves, then they were falling under the category of alkenes. And if they were having triple bond among themselves, they were falling under the category of alkynes. Here, this functional group, we will not be classifying them as alkane, alkene or alkyne, anything. They are simply, this is because they are simply formed by the double bond between a carbon atom and a heteroatom. Okay. So here, all the carbon atoms are bonded by a single bond among themselves. Therefore, the name was supposed to be ethane and a suffix of Al was supposed to be associated with it. Again, the same discrepancy is arising here. I am having a E and a A together. So, what IUPAC has suggested? We will omit this E and we will place Al instead of them. So the name becomes ethanol. Okay. Wherever you see Al, that means the functional group here is that of a aldehyde. If you see Ol, then the functional group is that of a alcohol. Okay. Now the next functional group which I am having is, now if you have facing any problem in nomenclature, don't worry. After this, after dealing with all the functional groups together, we will move on to the examples of how we actually give the name to the hydrocarbons having different functional groups. Okay. So don't worry for that. We have solution to everything. So the next functional group which we are dealing is the fourth functional group, which is ketone. Okay. The fourth functional group which we have in hand here is that of a ketone. Now, what is the general formula for ketone? See, C double bond O. And to this, any other atom will be associated apart from hydrogen. If at any carbon, if this in this carbon, any side you see there is a presence of a hydrogen group, then that turns out to be the functional group of aldehydes. Okay, that's the difference between aldehyde and ketone. In case of aldehyde, I was having the same C double bond O group, but there was a hydrogen associated to the carbon atom bonded to the oxygen. This is the mandate. Okay, this is the mandatory condition for aldehydic functional group. But for ketonic functional group, you have C double bond O and the other sides must be satisfied by other carbon atoms only. Okay, this is the mandatory condition for a aldehyde and a ketone. So for a ketone, the functional group is here only C double bond O. Right. So the functional group here is C double bond O. So that means for a carbon ketone group to exist, it must be bonded to two other carbon atoms. So the lowest ketone which you can get is that of a 3 carbon atoms. So the ketone functional group starts from a 3 carbon atom compound. Okay. It can have no any less carbon atoms present in its functional group. It has to have minimum of 3 carbon atoms. Okay. And the suffix or for the nomenclature, IUPAC has instructed us to use a suffix of ONE, on. Okay, it has to have a suffix of ONE. Now, if I see the general ketone CH3, C double bond O, CH3. Here, how many carbon atoms I'm having? 3 carbon atoms in my parent chain. So the word root that should follow is prop, and all are doubly or all are singly bonded, and the only double bond present is between a carbon and the oxygen, which is a heteroatom. So it will not fall under the category of alkane, alkene or alkyne. So simply the name should be propane and the suffix associated should be ONE. But again, E and O, so we have to remove remove the E from it, and we have to associate the suffix of ONE, and the name becomes propanone. Okay, the name of this particular organic compound is propanone, right? So the next or the probably the last functional group in your syllabus is, as such we are having a lot of functional group, but the last one from your syllabus is that of a carboxylic acid. The fifth functional group is a carboxylic acid. Okay, so the general formula for it is C double bond O, OH. Okay, now see, it might look familiar to that of alcohol, because for alcohol we were having a COH bond, but in case of carboxylic acid, you have a C double bond O intervening between them. Okay, the C carbon and OH group are not directly connected, but there is an intervening C double bond O in between them. So the COOH group is an acidic group, and the general name for organic acid is carboxylic acid. Okay. Now, what IUPAC has said us is, what IUPAC has instructed us, for its nomenclature, we have to use a suffix OIC, acid. Okay, we have to use the suffix of OIC, acid. For example, if I'm saying CH3 COOH, okay, it can be represented like that also. It is the expanded form, and in short it can be represented as COOH. Now, if you have a compound like this, here how many carbon atoms are there? What I have said, if the functional group contains the carbon atom, then we have to include that carbon atom also in the naming of our parent chain. So here there are 2 carbon atoms present. So the word root that follows will be eth, and it is all singly bonded. All the carbon atoms are singly bonded to each other. Therefore, the name should be ethane, and with a suffix of OIC, acid. But again, EO together, not possible. So it will be ethanoic acid. Okay. So we have dealt with 5 functional groups here. Now let us summarize what we have dealt with all the 5 functional groups. The first functional group which we had was that of a halogen group. Okay, that is the haloalkane. So if I'm writing the summary, then here I'm writing the functional group. And there we will be writing the suffix or the prefix associated. So if I'm saying the halogen group CX, this is the halo compound, and the prefix which we were associating was that of a haloalkane. Halo was the prefix. Okay. Next we saw alcohol, COH. The suffix which associated was OL. Okay, this was the suffix. Now if I will see the aldehydic group, okay, here the suffix which was associated was Al. For ketones, the suffix was ONE, and for carboxylic acid, the suffix was OIC, acid, which is the suffix. Okay, so we have majorly seen these 5 functional groups. Now after having an idea about functional group, we will see how the nomenclature is exactly done in the case of the following functional groups. So let us move on to some questions. Okay, so the first question before us is that of a, like if I ask you to identify the functional group which is present, you don't have to look at all at the number of carbon atoms or hydrogen atoms or so and so. You simply have to look at the heteroatom associated, and you can just come down to the, or you can conclude to the functional group which is present in that particular compound. So if I see this case, here at the end I am having a heteroatom of chlorine. Therefore, it belongs to the chlorofunctional group or halofunctional group, right? Or halides. It falls under the category of halides. So for writing the names of the halide, what I had to do? I had to use a suffix of halo. Got it? So we will start our naming. How many carbon atoms are there? 1, 2, 3, 4. 4 carbon atoms. But when we are having the functional group associated to it, what rule we have to follow is, first priority or the first carbon atom should be the one which is nearer to the halogen or the particular heteroatom group or the functional group. So here if I see the compound is the compound starts from a chlorine as a heteroatom. So the naming should start from the carbon atom just adjacent to the chlorine atom. So from where my naming will start? This will be my first carbon, this is the second carbon, third and fourth carbon. So how many carbon atoms I'm having here? 4 carbon atoms. So the word root that follows 4 carbon atom is but. Now all are alkane here, all are singly bonded. Therefore, I have to write ANE to signify it as a alkane. Okay. Butane, and I am having a chlorine group associated to the butane. Therefore, I have to add a suffix of halo. And for chlorine, the suffix was chloro. So I will write chlorobutane. Okay. Chlorobutane. Got it? So as there was a chlorine functional group associated to my alkane, therefore I have to name it chlorobutane. Now if I see the second example, again the naming will start from the carbon atom just immediate to the functional group, which is bromine. So the naming will start from this carbon. 1, 2, 3, 4 carbon atoms are there in this as well. And here the word root will be but, again to signify 4 carbon atoms. Okay. So but, and all the carbon atoms are singly bonded. Therefore, they fall into the category of alkanes. Therefore, I will write the name ANE or the suffix of ANE to signify alkanes. Now, the functional group I am having here is Br, bromine. So, the prefix which has to follow is bromo. Okay. So, it will be bromobutane. If iodine was there, then the suffix will be iodo, and if fluorine was there, the prefix will be fluoro. Okay. Now, if I see my third example, looking at the third example, I can say it is falling under the category of alcohols, right? And the naming has to start from the side having the functional group. So my naming will start from the carbon atom which is just adjacent to the OH group. Okay, so from here 1, 2, 3. There are 3 carbon atoms, and for 3 carbon atoms the word root which it has to follow is prop. And it is all alkanes, therefore the word root, the suffix which has to follow is ANE to signify that there are all singly bonded carbon atoms. So it will be propane. But as there is a functional group OH, what we have learnt is for a OH group, the suffix which it has to follow is OL. Okay, so it should be propane, OL, and E and O cannot exist together. Therefore, we have to cut down this E. We have to cut down the E and add OL. That becomes propanol. So the functional group or the carbon atom, or the compound I am having before me is that of a alcohol, and the name for it is propanol. Okay, we'll move on to the next example, which is CH3CH, C2H5, CH2, CH2OH. Now see, here I'm having a mixed condition. Here I'm having a branch chain also as well as a functional group also. So what I have to do, see, for the branching chain or branch chain nomenclature, we had a rule that the branching must get the minimum number. But here, before dealing with this question, the other questions what I have said is, we have to start the nomenclature or the naming from that carbon atom which is just adjacent to the functional group. Now you have two different contradictory statements. If I give the priority to the carbon atom which is just adjacent to the functional group, then my branch is not getting the minimum number. And if I try giving my branch the minimum number, then my carbon atom adjacent to the functional group is not getting the priority. In that case, what I have to do? See, in this contradictory situation, I have to give priority to my functional group. I have to start my naming from the carbon atom which is just adjacent to the functional group. Okay, I will not look at the branching then. After naming the carbon atom from my the functional group, then branching, I will just give the number to the branching, and I will not look into the fact that the branching is getting whether the branching is getting the minimum number or not. I'm least bothered about it when I'm having a functional group with me. Okay, so from here I will start my naming from this particular carbon atom 1, 2, 3, 4. Now if I try to expand this branch, then it is a ethyl group, that is CH2CH3 group. So if I expand it, I will get CH2 CH3. Now I have to look for the longest chain. Okay, the fact of choosing the longest chain remains inevitable, but the only fact which is changing is I have to give my priority to the functional group, that is whatever functional group is associated to that carbon, and I will not be hunting for the I will not be looking into giving the minimum number to my whatever the branch is there. Okay, I will simply focus on the functional group here. So if I see this, if I expand my the branch, I am getting CH2 CH3. Now I will see whether am I getting a longer chain other than the 4 carbon atom chain. So if I start naming from here 1, 2, 3, 4, 5. Of course, here I am getting a 5 carbon atom chain. So I have to choose this as my primary chain, and the fourth, this will become my branch. Okay, so here 5 carbon atoms are present. So the word root which follows is pent, and alcohol is there, all are singly bonded, so pentanol, right? But I'm having a branch at the third position also, so I have to name it 3-methyl pentanol. Now this signifies that I am having a functional group of alcohols, and there is a branching at the third position, and the branching is of a methyl group. Okay, now if I look the next example, CH3, CH2, CO, CH3. So here what I'm having the functional group of ketone. Okay, and how many carbon atoms I'm having? 1, 2, 3, 4. Okay, so there are 4 carbon atoms, and I am having a ketone at the second position. The second carbon atom is that of a ketone, right? So what I have to do for 4 carbon atoms, I have to show, or I have to give the nomenclature as, or the word root as but, and it should be ane, right? But in this case butane, and here in the second position I'm having a ketone, so butane 2 ONE. I have to show the position where my ketone group is present. So butanone. That means I am having a ketone as a functional group, and that ketone or that carbon atom containing the ketone functional group is present in the second group. Okay, so I am coming down to the name butanone, butane 2-ONE. Now the next example I am having is that of a carboxylic acid. If I look at the COOH group, this is a carboxylic acid. Now again, I will name this, I will include the functional group in my parent chain, because here the functional group is having a carbon atom. Okay, and I have said in those cases where the functional group is having a carbon atom, then that functional group's carbon atom is also included in the parent chain. Okay, so if I'm seeing this, then the naming will start from the COH group itself. The name will be 1, 2, 3, 4 and 5 carbon atoms. So the word root lies pent, and as all are singly bonded, so the name will be pentane, but oic acid has to be there, OIC acid, and E and O cannot be together, so the name becomes pentanoic acid. Okay, and if I see my last question, here I am getting C3H7 and the functional group here is CHO. Okay, and that functional group is that of a aldehydic group. So how many carbon atoms are there here? 1 and these 3. 4 carbon atoms are there. So the name will be but, and ane has to be there as because all are singly bonded. So butane, and for the case of, or in case of aldehydes, the prefix that should have followed is Al. So that is butanal. So the name of this compound comes out to be butanal. Okay. So in this video, we have dealt with the nomenclature of functional or carbon atoms or hydrocarbons containing the functional group. I hope you are clear on this fact. We will continue further in our next lecture. Thank you so much.